Hello, my name is Baart. I'm giving a talk who needs unit tests anyway. Bit of a provocative title. We'll see about that. Subtitle: Modernizing legacy code with 0% code coverage. This is my first ever talk at a conference, so please bear with me. Hopefully I'll get there in time. I'm a senior software engineer at Bittner & Software Systems, which is a German company located in Munich. We are doing all kinds of software for the energy industry, ranging from workforce management to smart meter reading, all kinds of stuff related to grid providers and the energy industry in large. Personally, I'm mostly working on desktop applications, which explains the legacy part of this talk, and also backend services for all kinds of other applications, both of which are being done in C++. So I'm 99% working in C++. So what is this talk going to be about? It's about legacy systems, modernizing them. So what are legacy systems? Well, there's a whole range of definitions, of course. For me personally, they are long-living systems. I wrote down 10 years, but often it's a lot more than that. Software I'm working on right now, the main product is about 25 years old. The one before that was even older and started live before C++ and was converted to a C++ application. They are large systems. It's usually part of all definitions of legacy systems. Large is a matter of opinion, of course. Define it here as 1 million lines of code, but you can start wherever you like. If it's legacy for you, that's fine. And if you say legacy systems, you're usually thinking about old-fashioned coding style, maybe not updated in a couple of years, or only in small parts. At least a lot of the code inside your code base will be old, and it shows. But maybe it also means insufficient automated tests. In the worst case, 0%, as the title says. Probably has poor documentation, because when you started in the 80s, 90s, early 2000s, you thought about documenting it. Maybe it was one developer who started it on his own for a couple of years. Who knows? And you might have a lot of working but outdated dependencies on other stuff. Frameworks, libraries, operating systems, 16 or 32-bit architecture, who knows? But what are they not always? But what are people usually thinking about as well when they talk about legacy systems? Unsupported systems, obsolete systems. By the way, all of these terms are part of the Wikipedia definition of legacy systems, which is quite interesting. They're out of date, in need of replacement, and lacking modern features. But for me, this is not a given. This is something you can work on, given the time and tools to do so. So that's why I'm giving this talk. Legacy systems are a major pain point for most companies who have large systems like that. And they're costly as well, as you probably know, otherwise you wouldn't be sitting here. But they're also widespread. In use, they are useful for the users, and they are valuable to the companies who are still maintaining them. Otherwise, they would have stopped doing so already. And this is often forgotten, they are tested, even with 0% code coverage. Why are they tested? They are tested in the field. The application has been successfully being sold and been running for 20 years. It's more or less tested and has proven itself, even if it still has bugs. So why modernize it at all? If it's running, it's providing value, just works. Well, you could take look at this in different ways. And what's usually happening first is you're looking at it from the point of view of the problems you're encountering with it. The code base is a nightmare to read, and every change is painful. There are dependencies which are life-threatening for the application. You're afraid that some of them might not be available anymore tomorrow. You're dependent on some system, a Microsoft library, whatever, that might be shut down from one moment to the next. And this might be a real problem for your business if it's one of your larger applications. Nobody wants to work on this code base. Maybe there are still some developers left who started it, maybe not. But you're having a really hard time getting new employees to work on it. Your headhunter is doing all he can, but he's not being successful. And there are a time sink. Okay, all of this is true, but it's a bit of a negative view. There are also some fears connected to modernizing, which might stop you from doing so. There's a general fear of change. We all know it. And the larger the company, the bigger this fear might be. You're afraid of breaking existing code. This is understandable. But you might also be afraid of alienating the few original developers of this code base who are still with you. This is a real problem because without their knowledge, you might be lost. And there's high costs involved, of course. If you're dedicating a whole team to a task like modernizing this system, it's going to be expensive. But for me, this is all a bit much negativity. So I'd like to put a positive spin on it. You can't see it on the slides, but every line here is basically a twist of the 8 negatives I gave earlier. Just putting it in a different perspective. So instead of saying, oh, it's so hard to read and change this code, you could say, I want to modernize it so I can improve maintainability. I can replace dependencies with modern alternatives, with a chance to improve the system. I can empower new developers by modernizing the system, helping them, getting them on board to do this, and putting them in charge. I can speed up development of new features if I modernize the system. I can keep evolving the code and application. I can actually increase the stability and reduce brittleness by modernizing it and doing all the steps necessary to reach this modern state. I can foster collaboration between veteran developers still in the company and junior developers who might do the modernizing. And I can actually reduce maintenance costs and generate income in the long term, which sounds quite good to me. So let's talk about modernizing. First of all, before we get into how do you modernize and what exactly are steps you can take, I want to talk about the human factor, because in my years of experience doing this kind of stuff, I've learned that the human factor is the most important one, actually. There's a lot of resentment, blame, unwillingness going on, and we have to do something about that if we want to modernize the system of this scale. So first of all, there's a psychological aspect, several actually. And you can do a couple of things to improve the modernization process for everyone involved. The first thing is start with the why. Explain to everyone involved why you want to modernize the system, what will be the benefits for everyone we discussed earlier, and we'll get into it later on as well, and get everyone on board this way. If you just tell them to do so, tell your teammates, maybe you're a manager telling your team to do so. Without any explanation, they won't be motivated, and no one has fun working on legacy code if he has no motivation. Another important aspect, to me at least, is show, don't tell. What do I mean with this? There's several aspects to this. First of all, you will get a lot of skepticism for certain changes. And you can talk about how a modern coding alternative is the same as some old idiom, all you want, but showing that it's actually true is a whole different matter. So you can use tools like Godbolt or whatever to actually show that you're not ruining the system, which is a sentiment you often get from veteran developers who are afraid that you are just going to make things worse. Another important aspect on the psychological side is to keep everyone in the loop. Keep them updated, all the stakeholders, keep them updated. What are you doing? Why are you doing it? As I said before. What's happening right now? What are the current steps? What's the plan? What's your time frame? What exactly do you want to change? What does modernization mean for you? And what is your goal for this modernization process? Because people need to know that you're not working on getting rid of the legacy system or replacing it somehow. You actually want to make it even more valuable to the company. And as I mentioned before, it's very important to take the veterans along with this process. Especially if they are the guys who did the initial work. Put in years of their life to get the system up and running. And you still have them. You should appreciate that and do everything you can to make them happy about these changes. Which again can foster collaboration because you can put teams together to work on this, made up of the veterans as well as junior developers taking over in a couple of years, and who knows else from your team. So that's the one side, but there's also a practical side to the human factor. And what do I mean with that? Let's take a look at this example. How exactly can you structure this process without alienating the veterans, without losing the support of the team, with getting new employees on board? Well, there's a couple of things you can do. First of all, I would suggest to create a dedicated team for this modernization. Why is that? Well, if you have a dedicated team, they can fully focus their attention on this task. That's obvious that it will produce better results. But it also means someone is responsible for this and can be approached. And it also, as usual with a team, it creates a motivation as a team in itself. It's working together. Another important thing I learned is that you have to find, and I mean find, gurus within your company or team. What do I mean with this? What I mean is, if you have a team which has been working on a legacy system, chances are high they are good at what they're doing, but they might not know the latest C++20, C++23, 17, whatever features, depending on what your legacy system is currently on. And you need someone, at least one person, rather more, who can be approached by veterans who don't know the new code, and they can just ask him about it. Of course, there can be trainings and everything, but you need someone who is approachable at all times, so people don't feel lost with the new things. You should also try to cultivate the right mindset. I will talk more about this mindset on the next slide. This is just a bullet point here. And as I mentioned, you also need to train. if you're switching from a system which is in C++11 or even older, and you want to start using C++20 features, there's a lot of stuff to catch up on, and you need to get everyone on board, and this involves a lot of training. But you can also make life easier for people who might have been coding in C++11 for 30 years. It doesn't work, but you know what I mean. And maybe have only 3 or 4 years left before their retirement. They are not motivated to learn something new, at least not all of it. It happens, that's just reality. And making life easier for them will help you in the long term. So what you can do is at least try to encapsulate the worst parts of the modernization from their point of view, which is the most cryptic, exotic stuff you're doing for some optimization reasons or whatever reason. So I talked about mindset here. Let's take a look at that. There are just some, let's say, mantras that you can follow, which will help you get into the right mindset, which is not a negative mindset. First of all, remind yourself and everyone on the team, it's not someone else's code, this legacy system, it's yours now. If you're modernizing it, it's your system, so take responsibility for it. Which also means don't blame developers who did something in the past. We all write bad code all the time. We know it's true. So keep that in mind and don't blame someone for doing something weirdly 15 years ago. And ask yourself, even if you claim so, do you really want to write a replacement for this application, which has 10 million lines of codes? Maybe not. But also think about the positive aspects for yourself. If you're improving bad code, that actually makes you a much better programmer. It's completely different from just writing on a blank slate. You get a much better understanding of our beautiful language, sometimes beautiful. And you might even learn some clever tricks or even wisdom by looking at the old code. You never know if you don't look. But if you're more inclined to look at the direct benefits for yourself, well, remind yourself that you're working on a critical and extremely important project for the company, which might be good for your career. And you even have a chance to become an irreplaceable part of the company if you're the one who knows everything about the system. So don't be afraid. And not being afraid also means not being afraid of change and changing the code, even if there are no unit tests. Because not having any unit tests right now does not mean there's no testing. As I mentioned before, the system is live, has been for years, so it has proven itself, but changes are risky. But even without unit tests, you're not delivering us the changes without any testing, right? You're testing it yourself, there's some integration tests going on, and all kinds of other tests. So don't be afraid of change in general. And remember, breaking stuff also happens if you're working on a new system. Might have been delivered last week for the first time. You can still easily introduce a breaking change, unit test or no unit test. Also, bugs are actually less likely to occur when you're doing deliberate refactorings than they are when you are forced to change code that you do not understand. So it's not that risky at all. It's less risky than having to change something in the system without any understanding. And once the code has been modernized to a certain degree, it's actually easier to fix if you introduce a bug. And just trust your skills. If you've been chosen to do this kind of task, or if you volunteered, you know what you're capable of. You've been chosen for your skills, so trust them. So, with all of this out of the way, how do you start? How do you actually modernize a system? Well, first of all, you have to start understanding it. You can't change a single line of code if you don't understand it at all. So the first thing you have to learn and have to do is some spelunking. This term, I stumbled upon it actually on a poll by Jason on Twitter. Someone replied to it. He did a poll about spending your time debugging and some other options, and someone replied, actually there's an option missing, and that's spelunking. I really like this one, so I put it in here. What does spelunking mean? It means making sense of the code. But first, some bad news. If you're completely new to reading code, this might not be the right task for you, but then you're probably not the one doing it anyway, so that shouldn't be a problem. You should have some experience reading code, obviously, but maybe not as much as you expect. If you want to understand the code, the best thing you can do is get a mentor, who already knows this code. If it's the original developer, that's of course your best option. If there's no original developer available anymore, let's just hope someone already had to work on this part of the code that you're trying to work on now. Get help from them. It's the best speed improvement you can get to understanding it. But keep in mind, if it's not the original developer, the guy you're asking might be wrong. Just keep that in mind. He did an analysis and changes maybe 2 years ago of the same code, but that might have been wrong. So one approach to understanding the code is find some safe havens. What do I mean with this? Well, if you have a couple of million lines of codes, that's overwhelming. But most of this code is really just peripheral. The business logic will be focused on some areas of it. There's a lot of fluff going on, especially if it's a UI application. There's so much UI fluff, which is not really that crucial. So try to find some core elements which are important in a lot of places of the application, which you start with. And once you have understood those, to a certain degree at least, you will have some points in the application which are used a lot, which you already understand. And that makes branching from there and understanding the rest much, much easier. Another strategy is to use anchor points. What do I mean with anchor points? Well, let's say you have a legacy system, there's been a bug reported for it, you don't know any of the code. You know the behavior, but there's no real logging going on. You just know that if you do this and this in the application, it doesn't work as it should. And let's assume there's no one to ask about, okay, how is this order processed or whatever. What can you do? Well, if you're using an IDE, a debugger, you can just pause it randomly, hope you're getting somewhere in a call stack, which is helpful, but that's not a good strategy. So try to get some anchor points in your code base which you can rely on to intercept most of the stuff going on. This can be, if it exists, within logging classes. It can be, if it's your UI application, it can be a dialog-based class. So Maybe it's every dialog that opens or every button press goes through the same base function somewhere. And you can just set a breakpoint there, even if you have no clue what's being called. You can just go there, set a breakpoint, and continue execution and see what's actually being called. You can use central helper functions, DB access functions. Depending on your application, there's a whole lot of different things you can look at for this, which can be really helpful, especially if there's no mentor you can ask. And finally, you need to learn to ignore the fluff within large amounts of code. If it's a legacy system, chances are high there are functions with more lines of code than you can imagine. I've seen some with over 100K lines of code, single function, which is not fun. So you have to find some strategies for yourself. It's different for everyone, how to spot what's actually going on in there. The names usually don't help in systems like that. That's the next problem. And one approach to find this core of the algorithm can be, depending on the function, just refactoring it before you even understand it, even if you discard the refactoring afterwards. By refactoring in this, I mean things like extracting functions, specific parts into a helper function, because then you will see, all right, I have to pass this and this. It's returning that and that. I can't mark this const for some reason, this parameter, and you will learn what's actually being modified, what's passed along, what's completely irrelevant, and so on. Especially making those parameters const, or even just modifying local variables, making them const just to see what happens, can be really helpful. Even making the whole function const can help you understand it. So that's the first step, getting to know the code base and developing strategies to understand code. If you're already capable of doing this on completely random code you haven't seen before, even better. But if not, you can also use IDEs to your advantage. Use dependent breakpoints and other modern strategies that they provide to get you to help you get a better understanding. But if it's still a bit much, the easiest thing to do is declutter your code base first. Because let's be honest, in a code base this large, there will be a lot of dead code. So try to use some tools first, maybe to remove this, and also remove any dependencies which are actually no longer in use. It's less stuff you have to understand. And removing the dead code, you could argue, well, I don't have to look at it if it's dead anywhere, but you don't notice. Maybe you're doing a full text search for a certain term because you're trying to find which function is actually doing the modification you're investigating, and then that code will slow you down a lot. Another thing you can do is you can get rid of old to-do comments. And you should. Because IDEs have support for this, for to-do comments. You can get tasks list, other stuff. And if there's a lot of old stuff around marked as to-do from 20 years ago, it's not helping you at all. It's just removing your ability to use this functionality of your development environment. So get rid of them. You don't have to remove them. You can just rename them because the tools usually search for certain terms like slash to do or whatever. So just do a search and replace to rename them legacy to do whatever, and then you're rid of them. You should also, if it exists, rename bad nomenclature. So what do I mean with that? All code bases have developed over time, so they have a lot of terms which are synonyms of each other being used. The domain might have changed quite a bit over the years, introducing new terms. You're still using the old ones somewhere. So a new developer getting on board, even if he knows the domain as it is right now, will not understand them. So you should try to rename these things to make reading the code much easier. And goes without saying, also try to rename any functions which are just plain wrong or don't have a real name, have some nonsensical name, helper functions just named helper something, helper 1, helper 2. I've seen it all. So, as I said, they should match the domain. And this can be done with the global search and replace in a lot of cases. You don't need any rename refactoring tools to do this. Another thing you can do removing is useless macros. Why? Well, they cause a lot of issues with tools you can use. Even just IntelliSense, if you're using Visual Studio, will have a lot of trouble with them. So if they're just macros which don't really serve a purpose, they've been used because the original dev loved macros or didn't know any better, try to replace them. So we have a bit less clutter in our code base now. But there might be a lot of problems with it still, which we have to fix before we actually modernize. We can fix existing code. And the easiest way to do this is, if it's not enabled yet, enable a high warning level. W4 or equivalent, maybe even all, but that might be a bit much. And actually handle the warnings. You don't have to fix them all, I'll get to that in a minute, but handle them all. It's not as hard as you think. The numbers might be really bad at first, 10,000s of warnings, but it doesn't actually take that long to fix them, as you might imagine. You should start with fixing every warning produced in headers, just because they are replicated in most tools everywhere where they're included. And the numbers will go down quickly if you do this first, and it will look much better. And of course, try to use a branch to do this, and try to fix one diagnostic per commit only. Just so it's easier to understand later on, easier to fix potential mistakes you did here, and get a nice history of what was actually changed and which diagnostics were fixed. But also allow disabling or suppressing specific warnings. Usually, for a new project, I would not suggest this, but anything is better than not enabling W4 and living with the problems. But if you have 20,000 string conversion warnings because you're using some weird old framework with a string class or whatever, and you know it works because it's a compiler extension or whatever that's making it work, just suppress the warning. Don't fix 20,000 string initializations. The next thing you can and should do after these fixes is actually updating the foundation of your system. What do I mean with that? Now we're getting to it. We can finally work on upgrading the language. If you're still on C++11 or whatever, that's what you want to do. You want to get to the newer version so you can actually use the modern features. I would suggest updating the compiler version first. There might be some unexpected behavior even with the same language version if you upgrade the compiler. So investigate that first, fix it, get it out of the way. Do it version by version. Don't jump. You're making life hard for yourself if you do that. And try to aim for the latest version. If you're modernizing anyways and doing this, try to go as far as you can. And again, handle all the new warnings that you get when updating. Also, try updating dependencies as far as possible and as far as it's possible without risk. Right now, you have a working system, so your dependencies are still okay, but you should work on this as well. Okay, we've reached a state where we have our code base on a new compiler, a new language version. By the way, a new compiler might also mean a newer version of your IDE if you're using one, which comes with a lot of benefits as well. So you've done all this, but before you actually start changing code in actual refactorings, I would suggest you also get your project settings on the same level. This makes maintenance and understanding things much easier, because if you're using different settings just because they happen to be different, usually it wasn't on purpose. Someone created a new project 20 years ago, some settings, they copied them from somewhere. Someone forgot to change a certain project when they changed all others. It's not intended, but it can cause problems because the compiler is not working with the same settings. As much as you can, try to get the same settings so you're looking at the same problems with the same conditions. Lots of examples for settings. There's an endless list, depending on your compiler, your build system, and so on. If you can, you should also set some new standards. Yes, this does mean some kind of style guide, even if it's just a simple one with some ground rules. But why? Well, if you're modernizing a system, you have devs who are changing code that was developed by someone else. There might be a lot of conflicts. But if you have a style guide which enforces certain things, there's no conflict anymore between your team members because they have no other choice than to do it this way. There might be a conflict between the person developing the style guide and the veterans. That's another topic. But you're protecting the team from clashes inside. So that's worth it. And also reduces your mental burden when jumping within the code base. Because if you don't have a style guide and you're looking at different parts of your code, it's completely different. You're used to one style of coding, let's say, include early returns, and then you're looking at a large function which has a single return point. And you have to think about this differently all the time. And so try to get it consistent as much as possible. And this means, if you can, actually auto-format all code. This is a bit controversial because you lose some version control history with that. You have a lot of changes which are just related to formatting. If it's not just white space, you will actually see the last change date based on this formatting, which can be a bit of a problem. But remember, the previous history is still there. It's just a bit harder to access. Okay, with that out of the way, you should do another thing before you change code. Introduce better tooling. You probably updated the IDE already when you did the compiler upgrades or even before that, but if you haven't yet, use this opportunity to introduce some static analyzers and get rid of even more bugs before you start changing code. Sanitizers as well, as far as applicable. But you can also introduce some package management to make life with the dependencies, even the old ones, easier for you. So now we're finally getting to changing code. And the first thing I would suggest is taking care of outdated APIs and types, internal types, external types. For API interaction, any API really, Win32, whatever, if it's not there yet, try to introduce a layer which interacts with this API. This has the advantage that not everyone needs to know the intricacies of this API. You just have persons responsible for this layer, and everyone else can use a newly designed interface to interact with it. You can also wrap outdated custom internal types as well as API or framework types. And if you're wrapping them inside some class, you can then later on, or maybe directly, depending on what it is exactly, replace them with modern alternatives. So ideally, types from a standard library. If you have your own array implementation, which has no purpose for existing, it's different if it's for performance reasons, then wrap it, replace it, if at all possible. If that's not possible, and if replacement is not possible, but you've wrapped it, you can try to improve this wrapper and make your types or the external types work better than before. An example for this could be you have some custom container type implemented from the legacy codebase, which does not yet support iterators. And you can add this to this wrapper class. So you can actually use it in the algorithms. If you have any custom implementations for problems which are already solved somewhere else in the world, try to deprecate them. Examples of this can be your own XML parser, your own socket library for sending emails, whatever. Yeah. Maybe there was no standard solution back then. Yeah, that's okay. And you maintained it until now, but try to switch to something which is maintained by someone else for these kind of things. Unless you have really good reasons to do it yourself. Don't reinvent the wheel. You'd had to invent it back then. Maybe, okay, still get rid of it, even if it hurts, because you put a lot of time into it. Unless, as mentioned before, you have good reasons to keep them, like performance reasons. And remember, even if you're using a ready-made library instead of your own custom implementation, that doesn't mean you can't enhance this external library somehow. Now that you've wrapped these types and your code base is more or less prepared for any change, you can start actually refactoring and getting the code in a better state. And the first thing I would suggest you can do is refactoring on the fly. What I mean with this is refactoring very small or even just cosmetic things as you encounter them. So you're trying to fix a bug, you're looking at a function, small function, 10 lines maybe, there's a bug in there. But other than the bug, there's a lot of weird names going on, stuff like that. You can just fix it as you go while you do the bug fix. This is a bit of a different approach than you usually read about. We'll get to that in a second. Remember, I'm talking about very small changes here, right here. Stuff where you absolutely know that it's not going to break anything. if you're renaming a local variable in a function, it's not going to break your code. You know this. Use the rename refactoring tools of your IDE if you want to be double sure, but you can get this done without breaking code. Trust your skills. This should be easy enough, even without the unit tests. This gradually improves readability and stability, which is a good thing, and it's more or less for free because you're looking at the code anyways, you're doing some typing there. Changing a few things will not cost you any time. It actually also helps you understand the code you want to change. If you think about new names, if you maybe extract a subfunction, this will help you. So it might actually speed up development. I would suggest that you do not enforce separate commits for this. This is a guideline you often read for refactoring. Keep the refactoring and the actual change separate. For these small changes, I would suggest not doing so because it hinders improving the code a lot. People will not rename the function, the local variable, to a slightly better name if they have to do 2 commits after each other for that. They just won't. In general, they're just too lazy. It's the truth. So try not to enforce this. I will give you some examples for refactorings on the fly that you can do. There's a lot more, of course, just so you get a better understanding which type of refactoring I mean. As I mentioned, renaming local variables, non-exported functions should be harmless enough. Marking local variables as const, or even the function you're working on, as long as it works. If this causes any kind of compiler warning or even error, you have to decide. Is it worth looking into? Is it something larger? Is there even a problem? But this, I would suggest, is then a thing you should fix in a separate commit as a proper refactoring. But if you can change it to const without any new warnings or errors, just do it. Yeah, you're just making the code safer. You have a local variable which wasn't const before. Now it is. No one can change it anymore. That's a good thing. If you have some weird framework-dependent legacy stuff which is no longer needed, this is an example from the MFC Microsoft framework, which is using null macros instead of null pointer, which we didn't have back then. Just replace it. With this example, be careful, null is used in several contexts. I'm talking about the pointer context here. But you can probably think of a lot of examples in your own code base like this. And if you stumble upon them, remove any completely pointless idioms that some developer 20 years ago had, like this example, where someone is checking a bool against 0, which is strictly not quite correct anyways. But there are also some slightly larger refactorings I would consider okay to do on the fly and commit in the same commit. Some examples for this. You can change functions to use guard clauses instead of deeply nested ifs. Why? Well, why it's the better approach? It's debatable, but if you agree with that, then you can change it because it helps you understand the code that you're looking at. Especially if you have to bug fix it, might help a lot to get rid of the nested ifs. And if you're doing that anyways, and you're already changing the code, why make life hard for yourself and try to get this into a different commit? it's not really necessary. Of course, this only applies if it's really quite a small function. You can still understand it. You can be sure that you did not invert some logic by doing this. Be careful. We all know how easy it is to add an exclamation mark or leave it out and invert everything. But this should still be a refactoring you can do on the fly if you're doing it anyways. I would not suggest doing this just because you can while changing a bug, fixing a bug, or improving a function. Another example would be just to replace classic for loop with the more modern equivalents. This should be completely harmless, but it's a few lines of more modern code introduced. Similar to the guard clauses, you can return single point of return logic with early returns if the function is easy enough to understand. If you're not sure you understand it, don't do it. Another harmless enough example is extracting a function. You might be surprised what happens, as I mentioned earlier. You think you're passing all the right parameters, you're passing them as you should pass them if you're developing it now, but it doesn't work. Some parameter needs to be modified by the function, surprisingly, and this might help you spot problems, even spot the thing you're actually investigating. Okay, so much for the small refactorings, but there's also larger ones. And the larger ones I would suggest to change explicitly. So have your own commit for these. Look at them as a separate task. Plan the refactoring, analyze the code, do the refactoring, commit it, independent of any open bug tickets or improvement tickets, whatever. This is a task for the dedicated team we mentioned earlier, while the on-the-fly refactoring can be done by anyone working on this code base. But pick your battles carefully. Don't start making a function const and end up doing a whole chain of 100 functions and you don't understand anymore what you're doing, or realizing at the 100th function that you actually can't make the whole call chain const. That would be a lot of wasted time. So be careful what you actually try to improve. And don't refactor just because you can. You should have a reason to do it. Even if the reason is gradually modernizing a certain class completely. That's fine. And that's your goal. And then you should. But just because you happen to see some old code, you will see a lot of it, you shouldn't refactor it just because you can. And in this case, as I mentioned, one commit per refactoring and also one refactoring per commit. It's not the same. And this focus just on the refactoring helps you avoid unintended changes, of course, even without the unit tests. As I mentioned, it separates refactoring and development. One benefit is also that you have an explicit change history, where you can see, okay, someone refactored this, maybe there's a comment which explains it. And this makes tracking down unintended change behavior much easier. As you're doing this, and as you're refactoring on the fly, you should also document as you go, because your documentation, let's be honest, will be lacking for this legacy system. This means commenting any existing code you had to analyze, if it's not already commented, of course. Add missing context to the comments. If you needed to talk about someone about the domain, or you use your own domain knowledge to actually understand what's happening, that means this comment was previously missing. You should add it. If you're doing the large refactorings, or especially really large ones, do comment them. Comment why you're doing it and what exactly you did. While you're at it, if you spot any comments which are clearly not right anymore, remove or change them. But be sure you are right about this. Otherwise, you might regret it a few years on. Okay, now if you've done all this, you're able to refactor. There's one topic left, and that's unit testing. I'm sorry. Yes, 0% code coverage was a lie. You might start like this, but it shouldn't be your goal, of course. Try to introduce unit testing, as much unit testing as you can. Don't spend too much time debating which testing framework. Any testing framework is better than no tests at all. So if for some reason you're still strongly tied to a certain framework which has its own unit testing like MFC, it's okay to use that. If it's easier for you, at least you will have some unit tests. And there are some rules about this. The larger your refactoring you want, the more you need tests. But unfortunately, the smaller your refactoring, the easier it is to actually write it. I can't help you solve that issue. That's just the truth. So with that being said, let me leave you with 2 recommendations for books. They take quite a different approach to this topic. The Legacy Code Programmer's Toolbox, as the title implies, is more or less a toolbox, but not just in terms of which tools can you use, but also which strategies can you use, which to actually refactor, but also to get the team on board, to get management on board, which is a topic I did skip today, and other related topics. The working effectively with legacy code is heavily unit test based, so you can still use this. It's absolutely valuable, but keep in mind that you will not be able to do everything as it's explained in there if you don't have any unit tests. If you can live with that, it's still worth the read, absolutely. So that's it. Thank you for listening.